My name is Andrew Fillingim. I'm with Ampere. Once you get your build all together, you're gonna start looking at thermal management, and this varies quite a bit based on, is this a day driver, is this your car, or are you gonna put it on a racetrack? The most temperamental things in your car are your batteries and probably your inverter. That heats up the quickest. Batteries, they really like to be in that basically 0 degrees C to 50 C. During driving, we've seen like Tesla likes to operate their batteries around 30 degrees C for just driving, and actually fast charge, they bump it up to 50 degrees C. There's a couple of different configurations you can do with your cooling, and again, this is kind of based on what the purpose of your build is. The simplest is you just have passive cooling. It takes a long time for batteries to heat up. If you're not driving that long of a time, then this is actually a good approach. It's simple, there's no coolant involved. You may have forced air cooling like what the original Toyota Prius design had, or you can have passive cooling like the Nissan Leaf setup. You still have to adhere to the battery temperature limits. The one downside to this, other than not being able to cool quickly, is you can actually get a lot of temperature variation across cells. Okay, you're gonna be driving this car quite a bit, you have a big battery pack, you're gonna add in some type of liquid cooling, heating as well. So normally you have a pump, your coolant loop that goes through your battery box, you'll have some type of high voltage heater if you need to heat the batteries. This configuration works for, I'd say, like 90% of builds. Now, if you're gonna start doing some racing and then you're doing fast charging and going back on the racetrack, you'll need to actually do some active cooling. And this is when you start getting into using an AC compressor to chill the battery, and you can actually get subambient cooling with this approach. A little more complicated because you're gonna have a three-way valve that will switch between normal cooling and heating to subambient cooling, and you have to add in that valve and also the additional AC loop. Then we get into more of the OEM level of cooling, which has lots of valves and pumps, and this is more, now we want to do full thermal management. We want to take the heat from our motor to warm our battery on startup. We want to be able to actively cool it with AC if it gets too hot. Lots of switching involved here. You get the benefit of higher efficiency, and also you're using the heat that your vehicle already produces to heat the battery. Now, if you're doing motorsports, there's some extra requirements. A lot of them require two main things. One is LED indicators, and one is being able to shut off high voltage, so high voltage switch. For the LED indicators, if you're doing racing, you want to make sure you have normally two indicators, one internal to the driver, one external to the driver. And this is just if for some reason you get on a wreck on the track, you know if there's high voltage on the system. They require that you have disconnects. If you're doing your own build yourself, this is probably a good idea anyways. That way you can always disconnect high voltage with an e-stop or a push of a button or a switch. Then long-term storage. So if you're doing a build and you have some batteries that are gonna sit for greater than a month, you wanna make sure you put the batteries in an environment that will let them last for a long time and not damage them. Disconnect 12 volts so there's no 12 volt drain and you don't kill your 12 volt battery. If you have a high voltage disconnect, go ahead and use it. Make sure it's in a nice dry environment, somewhere in the temperature range of -13 to 80 degrees Fahrenheit. If the SOC drops below 10%, you should charge it up to 30%.